Okay, so this issue is about adding. Are you recording now?
I believe we started, yeah.
Okay.
Yeah.
So this issue is about adding customization for the serialization of types in .NET for JSON. So specifically, like actually, it's gonna be easier to just show an example. Like what kind of customizations that would allow. So maybe let's start with the second example, which is something we already have in .NET, would be data contract attribute. So example customization you could do is you specify your resolver. You here inherit from the default one we provide as JSON implementation, and the contract, specifically what we call contract, is JSON type info in here. And JSON type info contains all of the stuff we need for the serialization. So specifically here, if we are serializing objects, we have things like properties, and we have also other knobs. So in this specific example, like we're gonna remove all of the properties we have on the contract. We're gonna get all of the properties with the data member attribute by reflection. We're gonna order them by the order property on the attribute, and we're gonna add them back to the contract. So in here, like we also specify like method, how do you get value of that specific property given the object, which happens to just match the reflection getter and setter. And also we do the same for the setter. So in this specific example, we've basically constructed simple contract for serialization, serialization using data contract attribute. So another example of things you can do is basically construct a contract for like how to serialize like a specific type from the scratch. So in example, I've created a simple type like my type which has a couple of like maybe weird properties. So it has like a name, it has a string ID for whatever reason, and then my property like hide name, like God knows like what someone would do with this. But anyway, like in this specific example, like we put some couple of values in the array, then we serialize the array, and then we can control things like if the ID will show up at all. In example here, like because ID is -1, we're not gonna show it, make it show in the serialized array. Also, we can control that the name doesn't show up by doing stuff inside of the contract, and basically, and I think we hopefully want to achieve. So like the way you achieve this is following. So on the options, on the JSON serializer options, you normally pass to the serialize method. You specify your custom resolver. So you set like a type info resolver, which would be in here my custom type, my custom resolver, which inherits from the default implementation. And we override the method get type info. It's you can also do it by constructing this completely from the scratch without using the default implementation. There is an interface we've provided for that, which default JSON type info resolver also implements, and you can either use that from the scratch or you go start from something which provides lots of defaults like in here. So in this specific example, like if it's not our type, we basically we do whatever the default does, and we ignore everything else. And in other case, like we start with constructing empty contract, and then we provide the create object method. Without this, you wouldn't be able to deserialize, because like the JSON serializer wouldn't know like how to construct the type. After that, we create property ID, which I call prop ID in here, and you do it by doing the JSON type info dot create JSON type property info of integer, which is the type for the property. You specify a getter, you specify a setter, And then you can also specify options like can serialize, which depending on the value can decide at the runtime if the value would be serialized or not. This is like in case someone has their own defaults, like in example, like for integers, the default value for integer would be 0. So like normally you have an option to ignore those values for serialization, but like if you want to change that to something else, like -1 or something else, you wouldn't be able to do that. With this, you can specify your own predicate. And similarly, we do the same for the property name. This is like the implementation detail here doesn't matter. It's more like what do you want to do with that. So so then you add it to the contract. So the properties is basically a list of properties you have, and then you add them. So I think it's now it's kind of like a good time to come into the API proposal. So the main piece of the API proposal is the iJSON type info resolver. So this thing is a type you have to provide, and this is your basically resolver. So all all this thing this type or interface does is, given a type, you provide a contract. And you have an option to not provide it. If you don't provide it, it will throw an exception. And the specific reason for this design choice of returning nullable in here is also conscious. This is so that in the future we can provide methods like combining resolvers. If someone wants to create the resolver for like a single type or something, they can combine multiple of them. If someone returns null, then you can combine them into one. Like currently, we didn't include that as part of the API review process, but we kind of are thinking forward of like what could be done in the future. And given that, we decided like, okay, it's probably a good idea to make this nullable, because if we didn't return anything, we threw an exception or something, then combination wouldn't be possible. You would have to basically know what the given resolver does in order to know if it's able to handle something or not. And that type info resolver is part of the JSON serialization options. So that you can obviously get and set the type info resolver here. The reason this guy requires a reference code, which is the linker attribute for telling you, hey, I'm doing something unsafe, is because we need to provide the default resolver, which is using reflection here. So if someone didn't set it at all and you would call getter, you would be doing something unsafe by using the reflection-based resolver. Like if you use a setter and then do get, it's technically not unsafe. You would still get a linker warning, but that we kind of think is the like a best experience, given you usually don't get it at all. Next thing, because we currently have a JSON serializer context type, which currently is not resolver per the current definition, but it meets all of the criteria of being resolver. So we decided it can as well implement iJSON type info resolver. So this is a type used by the source gen inside of the system.text.json. Like in here, we're doing the explicit interface implementation is because I believe it doesn't have options, so it wouldn't match the interface we have, but it's pretty close. I believe it's just get type info of type, and the options are constructor parameter to JSON serializer context. So this is the reason it cannot implicitly implement the interface. So another pieces of the puzzle here are basically the default JSON type info resolver. It's nothing fancy. It has just like literary constructor and virtual implementation of the get type info. Because it always returns the answer, it's not nullable answer in here. So if you're like inheriting from the default JSON type info resolver, you by default will not be able to benefit from the future kind of combination method, which might be added or might not be added, but at least in the closest future. But like if you use it, you know that you will get something usable or you will get an exception in the worst case if it's not possible. Like if you provide like a, I don't know, like a incomplete generic type or something like that, you will probably get an exception here.
What would be the use case for deriving from the default?
So the use case is simple. So currently we don't have any methods for the for combining resolvers. So it's not part of this API, but it most likely will be added in the future. That's my guess by the user scenarios I was James Newton King kind of gave us in the chat below. You can see the conversation actually in this specific issue. So the specific example is like that a library might provide a resolver which knows how to handle their own types. And you might want to combine that with the default resolver, basically. So if that guy takes precedence, you fall back to the default resolver. So and the reason why you might want to do it is like if you have like if you basically don't already know that you're not gonna use from other people's resolvers, you won't be combining them. But basically you can just as well inherit from the default JSON typing for resolver. I hope that answers your question, Eric.
Yeah, I think it did. Yeah, I guess it'd just be, you could do the same thing by encapsulating it, right? Or like implementing JSON type in full resolver yourself, having a field of default JSON.
Yeah, that's true. But the reason we provide it is is the question like why is this type provided at all, or like why
it's provided
at
all, but why do we think it needs to be inherited?
It doesn't technically. It doesn't need to be this doesn't need to be virtual. Like it's still going to be possible because you have an access to the interface and you could make it a field. We think it's basically easier to just override it, like in many cases. And because this method is called literally just once per type per options. And by you're recommended to store options between the serialization, then this like we think the perf in this specific scenario doesn't make much of the difference, and plus comparing to what this thing actually does, it's literally like is not going to save you anything by not having this virtual. So virtual is just a complacency.
Yeah, I think along the lines of what Eric's asking, I have a similar question, which is, it seems like from what you were saying earlier, moving forward, we would actually expect people to combine these things. So you get, someone from, you get one of these from somewhere else and you add some things to it, or you get two of these from somewhere else and you want to combine them in various ways. At which point you do the same thing with the default. Because if you get one from somewhere else, you're not going to be able to override what it's doing. So you're going to compose and you're going to encapsulate and do your own thing and then delegate to it or whatever. So creating a separate way to do it for the default feels a little bit weird. Like it'd be nice if there was just one way rather than one way, unless you're dealing with the default, in which case there's another way.
Fair enough. So yeah, so there are actually kind of two scenarios which people frequently use it. So one is when they construct the things from the scratch and they basically provide their own hierarchy. So like in example, like in the gRPC scenario, you know basically a specific set of types you're going to be using. And in other scenarios, people just edit like a single type, like modify it to their own use. So we kind of thought it's going to be easier to cover this specific like tiny scenario by just simply inheriting and overriding. But yeah, like I don't feel strongly about this being virtual or not, to be honest.
I apologize. I joined a little bit late. Did you show like what is the prototypical usage example of this earlier?
Yes, so there is a usage example, the two usage examples. So like what is showing the data member attribute, but yes, I did show it. So you can basically like offline kind of skim through this part and this part to show like what are the typical common use case scenarios basically. This one is actually a really good one because it uses the actual attribute we have.
Do all of the examples involve implementing this interface and implementing your own class that?
Currently, yes, you have to implement their own class. So
Okay.
because we don't currently have any proposed like methods for combining the resolvers, you have to implement your own class basically every time.
And we expect this to be a very common scenario, right? It just feels like it's pretty heavyweight.
Maybe, but it's also it's not like a super common people do that. Like we feel like if people have to do that, they maybe it's okay maybe to have another hoop and by creating their own class. Like,
Sorry, wait, what is that when you say don't do, like we're doing this whole feature because it's like an extremely common request to be able to do polymorphic deserialization, right?
So this is not about polymorphism. This is the customization of contracts.
I thought okay.
The meeting was misnamed.
Okay.
Yep. So yeah. So okay. So
maybe just to add. Sorry to interrupt. Just as I put it in chat as well, but basically, the inheritance pattern is pretty common in Newtonsoft in iContract resolver. So we basically just emulated that to make it easier for people to move over. It seemed like a straightforward thing, but you know, people can compose any way they want, really.
Yep. Imo, do you have any question? Because your hand is raised, and I'm not sure if you're asking or I cannot hear you if you're saying something, and I'm seeing you're unmuted.
So I have a question till Imo can talk. So yeah, if you create options and didn't specify any resolver, so
yep.
Does that default one will be used at that time, or?
Correct. You will use the default JSON type info resolver unless you're in the source gen mode.
So
then
basically,
in that case,
we can hear you now.
Yeah, we can hear you. And yeah, go ahead, Imo. Yeah, so to answer the question, yes, the default will be the default JSON type info resolver if you don't specify anything. And unless you're in the source gen mode, then this JSON serializer context will be your resolver. But that was because that guy actually creates option, I believe, for you. Imo, we cannot hear you, but I know you said something and I don't know what that was. So now's your time, I guess. Okay, I'll give you like 15 seconds and then.
Yeah, can you guys hear me now?
Yep.
Yeah, I think I was in a bad reception area. So my question is similar to the one that Stephen asked earlier. So why don't we do the same thing that we do for the converters, where basically you can register multiple of these guys, and then whoever returns a non-null value first is the one we pick.
Yeah, that's yeah.
I can try to answer that. Generally, there are many composition patterns that could be followed here. Like one would be chaining, which would work as you describe, and this is what we do with converters. But there's also like different forms of composition where essentially you're calling into other converters and making modifications on the result. That's also a very valid one, and that's like the primary use case we're looking at catering to. So essentially, we just want to have this one thing and then have users specify whether they want chaining or different forms of composition by doing their own combinators, or we might also consider authoring our own combinators should demand for this arise.
There is some comment on the chat. So the first who doesn't return null pattern is used by other serializers like WCF and binary formatter, but for as many years as I've been looking at those, I've never heard feedback that customers preferred one pattern over another.
Yeah, I guess it's a matter of like apples versus oranges. So that's why we're in the API review now, I guess. So let's maybe move forward, and then we can come back to this question later. So let me finish showing all of the possibilities we have here, and then we can maybe decide on why one way or another of doing this specific thing. So another kind of major point here is the JSON type info. So the JSON type info has a type which it's assigned to. So like once you construct the JSON type info, it has a one-to-one mapping with the specific type. And it is also tied to the specific options, and the converter will be like so the converter which options decided on will be also accessible by the converter property here. So the user actually cannot change this on the JSON type info. And then the kind thing, which allows you to tell if this thing actually if the properties will actually be used or not, if this is a numerable dictionary or like a custom converter or a value converter in some other type, we basically cannot change other things than like number handling maybe. And the properties, which is iList, the iList choice is kind of here. The reason we chose iList here is so that you can specify the order of properties. So there was basically two design choices here: either put order on the JSON property info, and make this iCollection, or iList, which implies the order. And so I went ahead with the iList here, which made more sense. And basically, when you use the default converter, you by default will get this sorted by the order. So we can also discuss this at a later point. Levi, I see your hand is raised.
You just mentioned JSON metadata kind a second ago.
Yep.
So JSON doesn't differentiate between object and dictionary. So are you talking, when you say JSON metadata kind, are you talking about like the on-wire representation or the .NET representation?
So this is kind of a bit related to the converter and their implementation. So basically, if this is set to object, that kind of implies this will use the internal object converter used by .NET. So basically, like I was kind of not sure if to add this at all into the JSON type info. But the reason this was added in the end was that like if you add properties and you're not actually an object, so say you're, I don't know, like your JSON type info of integer or something, and you add properties like you would, like I would currently throw an exception because like I don't know what to do with the properties, and user provided them. So, and you currently don't have a way to check if you are you can add the properties or not. So the way I decided to that was to provide the way of saying, okay, is this guy an object? Is this guy a numerable or a dictionary? So there is a kind of like a like how do you call it? It's a kind of metadata, basically, like we serialize. So like if user provides their own custom converter, and like we cannot basically tell like what they're gonna write to JSON. So like we don't know what they are gonna write, what kind of tokens they are gonna write to the stream. Like so like because we cannot tell that, that basically would be none always, like in those cases. But for objects or a numerable or a dictionary, we know what that type is. So for those guys, I can definitely tell, okay, this guy is actually serializing dictionary. So possibly in the future, like the dictionary will also be allowed to I don't know, like maybe extend properties with this guy. Currently, this only works with the object, like in the prototype. Obviously, we can redefine what that means. For enumerables, like it's also like kind of arguable, like perhaps like that's one of the design changes we're planning to think of in the future is like how do you specify the element converters. So for the enumerables and dictionaries, that would apply. For the things like custom converters, like we obviously cannot tell like what the user wrote in their custom converter. Like I cannot really like tell if they're gonna respect the settings or not. So like it's basically what we those cases. And the object could also be extended to something like object with parameterized constructors. So this doesn't refer specifically to like a specific JSON token type which would start the value. Like, so it doesn't refer to the like array in the array or an object in the JSON specifically. It's more like a internal representation of this specific JSON type info token.
Okay. Yeah, I think that makes sense. And so I guess my follow-up question would be, for something like a dictionary, I think you hinted that you might have a concept of like overflow properties in the future, which leads to kind of my next question. You have a bunch of different properties on JSON type info, number handling properties, create objects, stuff like that. Are all of those properties relevant to every type of JSON metadata kind?
So create object, yes, it is. Properties, it's not. Number handling is like if you're serializing a number, it will be relevant. Otherwise, it will be ignored always. And others, basically, there's nothing else here. So
I think maybe something that would be useful is fleshing out the usage examples that you had earlier, showing how each of these 4 different types might be consumed. I'll yield the floor now.
Just to mention that in source generation APIs, we have some different sort of holder types that contain this metadata, and they're different. There's one for objects, a different one for collections. So it might be worth like considering like splitting these APIs up. But I just wanted to mention that that's something we do in source gen, and that consideration is valid. That's it.
So you're saying that we essentially have a separate derived type for collection, separate derived type for enumerable, and separate derived type for dictionary, and they have relevant properties?
Perhaps it might make like validation simpler, especially if like perf and stuff is a consideration. Yeah, we do that for source gen.
For what it's worth, we're kind of constrained because JSON type info is already exposed, and the generic JSON type info of T is already exposed. So it would be tricky to fit all these things into the existing hierarchy. But for what it's worth, I think that's a good the way to look at JSON type info is that it is effectively a discriminated union between 3 kinds of converters that are configurable via metadata. And currently, the only one that is specific to POCOs is the properties list, but that's just a subset of the knobs that we'll be adding to this thing. So having a tag for that discriminated union kind of makes sense. I'm not necessarily convinced that we might be able to have other subtypes to JSON type info for these specific kinds.
Yeah, that makes sense.
okay, so let's continue maybe. So one of the kind of conventions we've done here is if something is nullable in here, that means there is most likely a matching property in the JSONs. In example, like number handling, so you can provide the JSON number handling attribute on the specific type, and that will like for the default converter, that will actually return whatever that attribute was set to. And similarly, we have similar thing on the JSON property info, which I will go into future in the future, like in few minutes actually. Okay, so let's finish the JSON type info. So there's also another type, JSON type info of T. And the only thing which this differs from this guy is that you can provide the type create object here. And the value of that is basically perf. So like if like internally currently every single JSON type info is JSON type info of T. And basically what that gives us is you can create an object without going back and forth between like basically object and T. So this is basically just perf optimization to have this guy. Technically speaking, like we could not expose it, and this could not be here, but then the perf for source gen definitely would suffer if we didn't have it. And also, like users might want to also benefit from actually having this as well on their like in their implementation. Like you pretty much always are constrained to some kind of T, and in many cases you basically know what the T is, and like you just want to use it. So, and if you don't provide it, obviously the serialization cannot happen because we don't know how to construct the specific object. So the properties now. So properties are bound to the options. So the options are there's a getter for the options here. Also, once you set a type on the property, you cannot change it. So we expose this type through this property. And the name also has a getter and setter. So every JSON property info needs a name. So it's also part of the static construction method I've created here for the create JSON property info. So it's required to provide a name, but the reason this also has a setter is in certain scenario you just want to modify the existing property. So having a setter here covers the scenario where you want to, like an example, I don't know, like maybe prefix every property with something or something along the lines, basically. Like I don't know what users might want to do. Specifically, we currently also have JSON naming policy, which you can already do most of the stuff with that. So yeah, technically it could maybe get away with not having this, but that's kind of like in my opinion, it makes it easier to expose it because the contract is basically like a manifestation of like all of the knobs we have elsewhere, and like it basically instantiates all of these options we created before, and now you can adjust the knobs basically further if you wanted, and otherwise like you don't touch the contracts. Okay, another thing here is the custom converter, which I don't know, it doesn't have a set here. It should have. I guess that's overlooked. So you know, it should have setter. I think it's happened because we renamed it last minute and probably disappeared along the way. Anyway, so the custom converter. The reason this has a custom prefix in here is because it can be set to null, and the null means here that this will be deducted from type, and the options will construct the converter for you, whatever the default is for the specific type. If you override it, then the specific property will use this custom converter, so you can do the customization for the specific property here, and also the non-generic version of the JSON property info has a getter and setter. If you look at the typed one, so the generic version, this will have a specific T on the getter and setter, so this is also perf optimization. So these guys will actually internally cast to this guy if you provide them. So because also internally every JSON property info will be JSON property info of T, so those guys will be translated into the typed version. So this will be slower if you go directly, but this is a convenience in many cases. You kind of don't care like about the tiny perf optimizations. In some cases you do. So depending on the use cases, it might be easier to provide it or not. So those specifically untyped versions are kind of optional, but it makes it for completeness. It kind of makes sense to add them, in my opinion, at least. It's because in many cases you don't care about perf that much and you care more about the flexibility of having this. Because in order to create the JSON property type info of T, you have to call the make generic like. If you have like an example, like in the gRPC scenario, you kind of have a list of all of the possible types and their getters and setters. So in this specific case, like basically, in order to call into the typed JSON property info of T, you have to use the reflection essentially to call into some of those APIs. So, but like doing that also gives you a perf benefit of this being faster. And if you don't do that and you use the generic, like non-generic APIs, it's still possible, but it will be slower. In cases of structs, it will actually do lots of boxing, and in certain scenarios, it will be actually pretty slow. And this was actually a specific request to have a typed version of getters and setters. That's actually coming from Jason Newton King's. Like my initial kind of pre-review actually didn't have the typed version at all, but James actually mentioned that it's a common scenario when you want to avoid boxing, and we want to have this actually be a first class scenario, and the non-generic version be a second class citizen, because if it's already slower, it might as well be slightly more slower. And another method here is the can serialize. It's the same with the for the type and non-typed version. So this basically, depending on the specific value of the property, you can decide if that specific property will show up in the serialized form or not. And another thing here is the number handling as well. This is the same NOP as was in the JSON type info, and it also matches the attribute behavior. So by default, you will get whatever the value you put on the attribute here. So I think that will conclude all of the APIs, and now I guess questions and pitchforks time.
So let me start then. So the options that you expose on the type info, what happens if I modify them? Can I, or are they read-only?
So yes, this is actually a good question. So this is a dual mode. So basically, at the moment when you're constructing contract, you can modify them for like whatever has a setter, it's modifiable. But like after it's used on the first serialization or deserialization, those options are locked and the type becomes immutable. And if you try to set it or something, it will throw.
And I didn't mean just the properties, also the options themselves at this JSON serializer options.
Yes,
that you expose
the entire options becomes immutable. I believe it's currently the case. I don't know if you've covered all the cases, but that's the intention at least, that the options becomes immutable after the first usage, and that includes all of the JSON type infos the contract resolver generated.
Where do those options, I mean, basically, I guess my question is also, when you have multiple instances of JSON type info, do they all share the options instance, or does each JSON type info have their own JSON serializer options, or how do I control which instance is going where?
So yes, each JSON type info is specific to options. So each options will have a separate JSON type info, because each option can have different resolver, and the different options might, because they provided different resolver, they might generate different type info for the same options and for the specific type. So because of that, the JSON type info is tied to options always, and you cannot share it between options, if that's the question.
I guess it was more the other way around, because you, like, each JSON type info has a JSON serializer options, but you're saying the other way around also holds. Each JSON serializer options has a JSON type info, I guess.
Yes, the JSON type info is kind of like constructed on demand. So basically, whenever the first time the specific type is used, the resolver will construct that specific JSON type info, and at that point it's also locked because it's also used at the same time, because that happens during the deserialization. But you technically could pre-generate the JSON type info before, then you return the specific instance in your resolver, but it will also become locked after the first user. So actually that happens in the case of the source gen. So that actually generates a bunch of properties which are JSON type infos. And in those cases, they are also modifiable in a sense until the first usage.
Yeah. And then, so the other question I have is, you basically propose that we have both the generic and the non-generic set get methods. So what happens if I set one or the other? Is basically when I set the generic one, is the non-generic one also initialized, or is the idea whatever is if the generic one is not null, we use it, regardless of whether a non-generic one is specified?
Source of truth is always this guy. So this guy will always be set. So no, sorry, not the typed one. And this guy will always produce the so the non-generic version will always kind of construct a new wrapper basically around it. Like there might be some caching happening and stuff like that, so it returns the same instance. But in general, like this is a source of truth.
So what happens then if I set a generic one and then I ask for the non-generic one? That means
you will get a delegate which translates one into the other basically, but it might be cached in somewhere.
Gotcha. So basically, it doesn't matter which one I set, the other one will always be in sync, basically.
Correct.
Okay, so then that makes sense. Then the other question I have is like you call these things can serialize, but based on your comment, it seems more like should serialize might be a better name.
Yeah, I mean actually, yes, yes, I agree. Maybe it's a better name.
Because I mean, to me, can serialize kind of like it sounds a bit weird, but basically what your comment says is like you're providing a delegate that says whether, based on the current value, whether we should write it out or not, right?
Yeah, I'm not much opinionated on the specific naming convention, so yes, I should serialize. Like, I think the Newtons of JSON might actually be calling it should serialize, if I remember correctly. So that's actually a good. Yeah, I agree.
Yeah, I think I picked it up from WinForms. I think the property grid has should serialize as well. That's why I was thinking of that. But yeah.
Are you writing the notes on the issue right now, or should I?
I just have my own notes on the side, but you're right.
Okay.
I should probably capture them. So yeah, let me write this up. Yeah, everything you said makes sense to me. The only thing I'm still not entirely sure about is kind of the. I think Eric explained this, that the user may want to kind of modify or adapt a JSON property, sorry, a JSON type info, which is why you think this, this converter style approach where you register multiple may not work. It seems like that's also what JSON.NET has been doing, right? There's only one contract resolver that you basically have to override and then, basically delegate to other instances. But I guess my imagination isn't strong enough. So can you describe how that would look like when somebody wants to just alter the behavior of an existing JSON type info and basically have their own things on top of that?
So yes, I think like actually James, like if you scroll down here, we actually have this specific conversation about this. So specific example here is like an example. The nhibernate and F# resolver might have their own resolvers, and then basically, like this is actually the specific design conversation we've had. Yeah. So basically, yeah, like we are not strongly like are in one camp or another in terms of like which design is better. It's still like apples and oranges, like whoever prefers one or another, and that's why we're kind of talking now in the API reviews to decide which apple is better, I guess.
Ultimately, in that conversation, we kind of built consensus that combinators should solve any composition pattern that comes to mind.
Yeah. So having the basically the interface which returns nullable like allows you to create any possible pattern you can possibly think of, while going with this one specific approach, like we are not 100% convinced that's the case. That was the consensus, I guess. But like maybe the pattern of like because like there are a couple of scenarios. An example, say someone created a default resolver and then they want nhibernate to take precedence over the default one, because like in the specific case, if you add nhibernate resolver later, then you would have to basically prepend it to the list, because otherwise default converter will always return the answer which is non-null, and in that case you will never actually get anything. So you also always have to prepend it on the list. So And that basically creates like a really starts basically kind of being a bit ugly, maybe. Like maybe the list should be considered like from the back to the front, maybe, like, and then it basically starts being like really vague on what the ordering should be. Like, while if you make it an interface, this is like very explicit. Like, okay, now user basically decides which way it goes. So we kind of start discussing different patterns, and like if we decide with the possible implementation here, this would be basically kind of like this. So you basically design the order, like you create the F# resolver. Okay, now this takes precedence over and Hibernate, and this takes precedence over the default JSON type info resolver. While in the other case, in case of a list, you kind of, I mean, it's kind of the same problem, but still the list will pretty much very frequently would have to be like very intentionally kind of created, while the combination pattern allows you, okay, I can now wrap and prepend very cheaply because like if you create a combinator, you can imagine like a simple implementation which implements the iJSON type info resolver, takes basically two implementations and combines left with the right one, and then you can prepend very cheaply with that. It's kind of creates like a tree pattern, I guess. But the list is kind of, I mean, it will also work, but you would have to know upfront all of the possible options here. And I think James even mentioned one of the options where you don't have control, like which one takes precedence. Like I think I can't remember where that specific example was, but he showed basically the example, I think, in the ASP.NET where you get that options instance in one of the callbacks, and then you basically can modify it in one specific place. I cannot remember where that. Oh yeah, I think it was specifically this example. So basically he has access to the type info resolver, the existing type info resolver now. Like if we didn't expose expose this option, and this would be a list, and maybe which would allow cheap prepending and appending, then maybe that would be better. But like, yes, we were not 100% convinced in either way, and like we think the just exposing the interface directly, that gives you kind of the most flexibility of all worlds.
I mean, the interface will be exposed in all cases, right? It's just a question: do you have a single one that is on the hook for dispatching versus a list, right?
Technically, it doesn't have to be. Like technically, it could be as well like a callback or something, and then like we could provide like a one implementation where you provide different callbacks. So that was also considered in
something to keep in mind is that we're retrofitting the contract resolver on top of the JSON serializer context, which is a source-gen specific thing, and the way that works currently is that it assumes a single JSON serializer options instance, a single JSON serializer context instance per options instance. And there had been discussions, like Laomi was pointing this out, that we might want to consider offering support to users to combine serialization contracts from multiple contexts. And I think that kind of fits into the same problem. But I still think that this should be in principle solvable via combinators, rather than having like a first-class list representation. Because as I pointed out, not all composition patterns are compatible with having a list. Like when you want to compose and mutate, that actually kind of falls apart.
Yes, like an example scenario of what Eric just mentioned. So it will be, say you have two classes generated from SourceGen, and you might want to pick like a couple of types from one and a couple from the other, and like now you're in the basically stuck because the list doesn't work.
And if you look at the top post in your screen right now, like I kind of sketched a couple of combinators that offer like common composition patterns, one using callbacks and one using chaining. In principle, both would be implementable using user code, but the question is, would we want to offer these out of the box or something like that out of the box?
Yeah, I guess my concern is, I mean, but also I think I don't quite understand enough about the JSON serialization with source yet. It's like my mental model is that for serialization operation, we have only one one options instance logically or one context logically. Is that true, or do we have already the case that doing a given serialization operation, different ones may be used based on which types are being involved?
Currently, there's a one-to-one mapping between options and contexts, and we were discussing possibly extending that. And actually, this feature would unlock composing multiple JSON serializer context generations. So,
well, I think conceptually, having one options instance and one context, even if it's a union context, is still like how I think about it. Like when would it make sense to use multiple options instances in the same routine? I don't think that's ever like a valid scenario. I don't know if
I agree with Lomi, because logically you serialize, right? And doing that serialization operation, you have to agree what your universe is, right? And so maybe there's a meta universe that aggregates universes, right? But like logically there has to be one, right? For a given type, you have to decide what resolver to use, right?
I mean, one use case I can think of is consider you're consuming a NuGet package that already has source generated contracts for a set of types that it exposes. And you want to consume these and combine them with certain POCOs that you're interested in. For example, like envelope classes. Currently, there's no way to do this other than falling back to reflection for your types. So I think it's conceivable, and I don't think there's anything inconsistent about it to just compose multiple sources for metadata.
Yeah, but basically you're proposing then you have a context that allows you somehow to aggregate multiple other contexts. But then at the end of the day, you get one context out that you can pass to serialize, right? You never have a case where you would say serialize with an iron removal of context or something, right? Because,
no.
Well, what would that even mean, right?
Well, in this proposal, you don't actually have any JSON serializer contexts that are aggregates, but you have in the iJSON type resolver that could act as an aggregate.
Right.
I think that's the difference.
Yeah, I guess I think your then is basically saying walk them in order, and whatever returns a non-null first is the one I pick, right?
Yeah, but basically, I would say we should not do this by default using magic. We should just, if users want to compose, we give them the interface and let them go nuts.
So that one I agree with. I just think I think what concerns me a little bit is that we're basically saying we don't propose a solution here yet, because I mean the very first thing a user wants to do is when they install, let's say, the Azure SDK, is somehow figure out how their types and the Azure SDK types are both basically being resolved, right? So like I think there needs to be a somewhat default answer for how you normally compose across multiple NuGet packages with their own contracts, right? And I think to me it's reasonable to say we have some sort of default things. I mean, what you have on screen right now looks pretty powerful, and then the rest is just, well, you implement your own AJSON type resolver and you write the switch or if statement in there yourself. But we have pretty common patterns that will generally accommodate 99 percentile. Maybe what you have on screen is already more than we need, but I think we would want something very simple that, let's say you write the Azure SDK docs, which you could recommend people to get started, right? I think if you immediately start with please derive from this type and write an if statement, like that's a pretty hard bar to enter.
Yeah, I agree that we need to have like a best practices documentation explaining how you do this kind of thing. Like one example I can think is like mixing and matching 3 different JSON serializer contexts and then doing a bit of reflection-based F# contract resolution, and then mix in a bit of an hibernate. Like, what's the best way to do this? The answer: there is no best way. But no, we're not going to write that. But I guess I'm saying there might be a way to do this for same scenario, if that makes sense.
Yeah. And also, I guess my other question is like, is this like this whole thing, do you think this is an advanced scenario, or do you think this is a kind of just an orthogonal way to do with, if you don't like attributes, you use this approach, for example?
Well, sometimes you cannot add attributes to something which already shipped elsewhere, right? Like in certain scenarios, like you have a NuGet package, you're stuck with it, right, and you don't have any other options. So it's an alternative way to provide it. In some cases, people don't want to pollute their code for various reasons. So yes, basically.
When you're using Newtonsoft, actually extending the contract resolver is pretty standard. Like, for example, you extend the contract resolver to do like camel case property naming, which we have like a separate feature that does that already. So I think users are kind of, I think they're familiar with this abstraction, and I think they'll be able to get things done with it.
Yeah, but I think to answer the question, I think that's not super common. I mean, I personally never had to do that, so like I guess I maybe not like an average like a web user who does this like insanely large amount of times, but I
I mean,
but I
that's
guess
kind of,
it's not basic scenario definitely. So
yeah, the reason I'm asking is because it kind of controls on how much time we spend on, for example, providing some sort of default experience for how you combine them. Because if we think it's super advanced, then I think it's fine to say, you write it yourself. If we think it's decently common, which is, I kind of agree with Eric, based on my experience with JSON.NET, it seems more common. It's possible that in system text.json it's less common because some stuff is already built in, like the casing, for example, that people don't have to do it as often. But it seems to me we should, just from an API evolution standpoint, also, it kind of makes me nervous to say we have this, mythical combinator feature that we haven't really designed yet, and we think it will solve everything, but then when we actually try to add it, it might be difficult. So I think we should probably, sketch out the design sufficiently that we would say, yeah, we would be willing to ship that, and maybe we actually end up shipping that.
Yeah. I wouldn't mind including something like that, just to give us the opportunity to test the design.
Yeah, because I mean that's really where you find out. I think you have to implement a few of them to actually see, how you can delegate and whether you have the right kind of patterns on the type and the right shape to do that. And some stuff might be difficult to change later, right? For example, making things virtual, or providing setters or getters for things that we don't have. Is there any other question? I kind of took a lot of time.
Just something I'm curious about, like, does the untyped, getters and setters on JSON property info have any like polymorphism considerations we need to be careful about? Or Christoph or Eric?
Polymorphism in what sense?
Like, say you have a declared type of some type, and then the type
Converter.
return, the converter is of a different type, or the type returned by the setter is of a different type.
So the converter is very intentionally untyped for that reason, because it might not exactly match the T type of the generic classes, and it might actually be a factory, in which case it's not typed at all.
Yeah, so this is specifically the piece of code he's talking about. So yeah, there is no matching typed version.
Yeah. Now the T type in the getters and setters, that shouldn't be an issue, because if the declared type is T for the property, then whatever the runtime type is, it should still be assignable to T.
I see. I just know that part of the code has been thorny, like especially with the reference stuff. So just checking. Sounds good. Thank you.
I mean, I might want to raise an open design question for JSON property info of T, and I have shared this already with Christoph, but I will say that the JSON property info of T strikes me as odd, because I don't necessarily, when looking at the type, I'm not necessarily sure whether the T type corresponds to the declaring type or the property type. Now, that being said, this actually reflects how the internal implementation is currently using getters and setters. Like the declaring type is boxed and the property type is strongly typed, and there are reasons for that. Like for example, it enables setters for structs actually working. But I guess my question is, and Christoph mentioned that James has a use case for this, but I'm wondering, should we like, do we actually need a generic JSON property info of T? Could we, for the MVP, could we unblock users by just using the untyped variant?
Just the first part of your question there is like, what does the T refer to? I think internally the T is the converter, T converter, but
it's the declaring it's the property type of the property.
As much as this guy.
the type that the converter is, the converter instance returns. That's at least as of 6.0. I'm not sure if I mean, I believe the T refers to what the converter returns, the converter instance returns. Not the declare type strictly or like the runtime type strictly, or however we define those.
I think that's no longer the case. Like actually now that's it actually fully matches the declaring type of the property. Like that's been changed in 7, I mean.
That's interesting. We yield it for the second half of your question around whether this type is needed to be exposed right now.
I mean, it technically doesn't have to exist, but yes, as I mentioned, that was one of the requests we got from from James to.
And I guess the reason why
that's one of the purge scenarios. Basically, he mentioned like which is really important to him. That's basically the feedback I got. That was the feedback I got after I provided the version without this type. So.
Yeah, I mean, sure, you might end up boxing a few integers when you're getting and setting them. I'm not necessarily sure that this would substantially contribute to the performance of serialization overall. But the reason why I'm bringing this up is, and I did bring it up in the comments, is should we look at in the future exposing a JSON property info that is generic both on the declaring type and the property type, and as such have like a func from T declaring type to T property type, obviously with the understanding that this would be complicated to get right for structs in the setter case.
We had a similar notion back in 3.0, but then the implementation, I don't remember the details, but the implementation wasn't very, didn't work well with some platforms like Xamarin and Android. So I know Steve spent a lot of time refactoring to simplify this to have a single T, and a lot of those problems like disappeared. So I mean, I'll just like verify that we're running all tests on all those platforms before.
Yeah, as you mentioned, the structs are like really become like really weird once you introduce the declaring type.
Yeah, but
like the setter is basically really easy to get wrong.
If you scroll down to one of my comments, like actually to get the setter to work in this example, you actually need to perform an unsafe unbox. So it works technically, but it is introducing a footgun for users that might just want to set a value in a struct. Yeah, so this is basically how SourceGen implements setters at the moment using the current API shape. So we're essentially making this the default way of expressing setters given the API. And for what it's worth, that's also true for the box variant, unless you do reflection-based set.
Can you explain why you need the unsafe one? Because you need the original one, not a copy.
Yeah, you want to set the value in the box value rather than the copy that you would be creating if you were casting.
Right.
Yeah, and if the T was generic, then you would always get a copy basically, because there is nothing to unbox.
Yeah.
Are we handling this generally correctly in the serializer? Because it seems like anything that goes via reflection will invariably get boxed at some point.
Say again?
Like, isn't that a general problem? Basically, my question is, if I serialize structs today, do we handle this correctly in all the places where it matters? Because
internally, yeah, we're definitely taking care that this doesn't happen. I mean, struct serialization is working in system.txt.json last time I checked. But the thing is, my concern is that we might be pushing that responsibility off to the user, and that kind of makes me worry about the design. Like, sure, internally it works fine if you're careful, but there's an element of unsafeness here that makes me think that should we just expose the untyped variants and say, just use property info.set value on the box things and have it work as expected? And perhaps we might consider a different design in future releases.
So you're proposing basically to make them non-settable, or you're proposing to remove them and only have the typed ones?
Only have the untyped ones for now. And in the future, like one possible solution is, like if you look at the very last line in Christoph's screen, there's an alternative way of declaring a setter, for example, where you always need to return the value of the struct. Of course, that's not optimal, but that's one possible design. And there's a few more, like you can use special delegates that accept ref parameters. So if you scroll down, Christoph, just a bit, you might be able to define a setter that accepts the declaring type by ref, and you should be able to define a setter that works as expected. But again, this is kind of open design space. I don't think we should try to make any decision here, which again makes me think that maybe we should refrain from taking action on the generic JSON property info APIs in general and just use the untyped ones for now.
Maybe I'm missing something, but I don't understand how the untyped one. If we only have the untyped ones, how does it solve the copy problem? Doesn't it make it worse?
It doesn't, but the untyped version kind of emphasizes that the only way you can do this is by using reflection-based setting. So you either do a field info.set value or property info.set value. Having something that is generic for quote performance means that people might assume that, oh, I'm just going to use it like doing a normal property set, only that doesn't actually work as expected for structs.
You're saying the generic one we just can't make work at all?
We can make it work, but you need to do an unsafe unbox.
So maybe I'm missing something, but isn't the line that you have on screen right now, isn't that basically the non-generic setter?
So which line are you referring to?
The second one. The JSON property info, no, like up on the screen.
This?
JSON property info dot setter, yeah, this one.
So in this case, it is generic with respect to the value, but it is non-generic with respect to the object. So I'm saying, why should we have something that is just generic with respect to the that is just generic with respect to the property type, but not generic with respect to the object, when you can't really use it in a full-blown way.
I see what you're saying. So yeah, I guess that was my mental model. It's like as soon as the object is like the receiver effectively is boxed, you are kind of screwed with structs, right?
Yeah.
That's when you have to do the unsafe thing.
Well, you're not screwed. You can get unblocked, but it introduces a footgun.
So you're saying if you use the reflection APIs, it will work because reflection of the covers does effectively an unsafe unbox?
I guess I'm saying that just surfacing the untyped JSON property info type that exposes getters and setters in the dumb way of taking a couple of objects and returning void, that kind of emphasizes the fact that you're better off using reflection for this one. And
honestly, like the way I'm looking at this, it's really an advanced feature, and using the setters is even more advanced because like normally people would probably just edit, and like in an entire gRPC scenario, like James actually never uses even a single struct, so he didn't even have this problem. So kind of makes me think like if that 1% or less of the users who would even use this feature, like would have this problem, they would basically immediately find an answer somewhere like how to use this structs.
Which makes me think, should we just remove the generic JSON property info altogether and offer the untyped one? And we can iterate in the future with some design.
I kind of lost at like what you mean by advanced scenario. Like, is it the setter that is advanced, or is it the using structs with this whole thing is advanced? Like, I'm inclined to believe that using structs in serialization is a bit more advanced, but I don't know. Intercepting the getter and setter seems somewhat sensible, right? If you want to modify the value somehow.
I mean, to me, this specific design using the ref of the declaring type would make the reference types, the experience for the reference types weird, but it would make the structs, I guess, normal. But like, yeah, like I guess either the reference types will suffer or the structs will suffer. Like we have to pick one way or one word or another, and like I guess. We are now consistent with what the reflection is doing, like if we stay with the current design. So I don't know, I guess it's still...
I mean, I'm not saying that we do what I propose here. I'm saying that maybe we should push this out to some future iteration, provided that there's demand. Because I don't see any scenario that is unblocked that is blocked by the absence of the generic variants.
I mean, perf, I guess, but...
Well, I mean, you'd be surprised because internally it's not given that we'll be consuming these getters and setters in the way that you might expect. Like boxing might still occur.
You mean even if you have generic ones?
Yeah.
Yeah, that's kind of why I was asking whether structs work properly already, because it seems hard to believe that we don't box at some point.
I guess another way of looking at this is, do we have benchmark numbers saying that actually when we use the strongly typed getters and setters, we got like a 10% performance improvement?
No. I kind of trusted James's judgment here. That's gonna be my answer here.
Bust but verify. No, I think it's a good question. I mean, to me, the other question that I still try to figure out in my head is how I should think of this is with source generation. So how does source generation play into this when I have my own JSON type resolver?
That's a good question. In the case of sourcegen, the getters and setters have the exact same signature as the generic JSON property info. However, it is not expected of users to actually consume these APIs. These APIs are consumed by the C# code that we generate in the first place. So there's no footgun as such to be considered in the case of sourcegen. In the case of users arbitrarily calling into getter and setter APIs, that's a different story.
Well, I guess my question was not specific to getters and setters. It was just more general about how do I use source generation and have my own resolvers? How does that compose?
You might be able to compose it any way you like, in the sense that JSON serializer context is an instance of a resolver that returns a nullable result, because it obviously hasn't generated metadata for every single type in .NET. So it's basically up to you to decide whether you want to chain multiple instances, implementations of the interface, be it instances of JSON serializer context, or be it reflection-based stuff that mutate metadata. Like I don't think there's one true way of doing it, if that answers your question.
So basically you're saying that, so the source generator spits out a context which implements iJSON type info resolver.
Correct.
Then I write my own with whatever basically I just either extend the default JSON type info resolver or I just implement my own interface myself. And then I choose to delegate to the JSON serializer context one that I got generated, or I have my own things on top. And then when I actually serialize, I presumably set the, yeah, that's the thing I don't understand. Like, how do I now plug in my own type resolver into this thing? Via the options, but I thought we don't use options in the source generator case.
So in sourcegen, what happens is there's this private field that is currently not settable from the outside. It's being set by the JSON serializer context itself. And that is creating a one-to-one coupling between a JSON serializer options instance and a JSON serializer context instance, and that cannot be changed. Now, the change that this feature will bring is that it replaces this field that is currently of type JSON serializer context with a publicly settable property that is of the interface type. So the existing source-gen scenario would work by setting, assigning that interface property to whatever JSON serializer context we're passing.
Yeah, that's my question. How do you pass it in? Because I mean, you basically have a JSON serializer context that implements the interface.
So
but it doesn't seem there's a constructor that takes another type resolver, for example, right?
So the way that you do this in SourceGen is that essentially your generated JSON serializer context will create an options instance for you that you can use to pass into the different APIs, although that's not the standard way of doing it. And that will make sure that it is assigned the right context instance for resolving the metadata. And that is a special case of what is being proposed here, where you have a general purpose property that you can use to assign arbitrary metadata resolvers. Now for SourceGen, for the SourceGen case, I'm assuming that what is going to happen is that we're going to lock the options instance that has been generated, that has been instantiated in the context of a generated JSON serializer context instance.
So I guess what you're saying is I would. So the JSON serializer context that I get has an options property that in of it that then itself has a type resolver that is initialized presumably to its containing serializer context, and then I would just override this with my own.
So basically, I think the main way to look at this is that JSON serializer options that are instantiated within the context of a JSON serializer context are locked to that resolver, and any attempts to overwrite that would probably result in invalid operation exception because the JSON serializer options would be locked. But for other things, other JSON serializer options instances that you create via the existing constructor, you should be able to assign any type of resolver, be it a context, be it a combinator that combines like 50 different contexts in a in a chaining way or in a mutating way or whatever you like.
So what are the factories you're referring to?
Factory.
You said like that you
constructor. So if you scroll down, Christoph, if you scroll down to the examples, yeah, so when you create a JSON serializer options by calling into its default constructor, then you should be able to set a type info resolver using your custom resolver. Now, if you get the options from a generated JSON serializer context, the type info resolver should already be populated and it should contain an instance of that JSON serializer context.
Yeah, I guess that is kind of what I was saying. Like my recollection, and maybe that's wrong, but like wasn't the idea that if I want to use source generated stuff, then I'm not using the APIs that take options, that take the API. I use the APIs that take the context.
Correct.
Is that not
correct?
Actually, you can do both ways. It's currently the code is kind of intermixed. Like every options will assign the context to itself, and the context will assign options. So basically, they create one-to-one mapping.
So it's a bidirectional relationship, and the reason why we did that was so that like users can use the existing APIs for people that didn't want to refactor all their code to
don't ask me about the why. I can tell you what's in the code.
No, I mean I was just saying why, and I guess my understanding of how this would work is like we generate the source gen will generate a context, and then the context will return type info instances. And I think it's at that layer that users might want to make changes. Like, so we give you like a type info that has a list of properties and all those type of things. And then you want to modify that list. So it sort of works in the same way. I guess I'm not
you're saying that you want a resolver that modifies the contract that has been created by the source generator?
That would be where I would think Imo's question was heading.
Yeah,
Alright,
my
but-
question is basically, and maybe this is old guidance based on where so I think originally we didn't have this mapping, right? This bidirectional mapping between the context and the options. So if you wanted to use the source generated ones, you had to use the serialized the serialized methods that take the context rather than the options, right? And so my question was, if I want to do that, but I also want to inject somehow my own contract, what would I do? And it sounds like what you're saying is, well, you can't use the one that takes the context. You have to use the one that takes the options, construct the options yourself, set the type resolver to whatever you want it to be, and then that's the outcome of that. And that's why I was asking, how does this compose with source generation? Because it sounds like it is not.
So the standard.
So if you use this conf property basically on the JSON serializer context, you can still use JSON serializer dot serialize or deserialize with the options, and that will still use the context. But if you would modify that to extend the contract resolver, you could technically change the behavior a bit.
So I trying to answer your question. The main methods that are used, like I think the recommended methods for doing source generation currently are the overloads that accept JSON type info of T as the parameter, because they also avoid the whole dictionary lookup and stuff. You can still get source generated contracts by either accepting the JSON serializer context or by passing the options instance that has been blessed with the JSON serializer context instance. And it will do like the relevant lookups and resolve to that. But if it doesn't, tough luck, it's going to fall back to reflection, unfortunately. But in terms of composing custom contracts with what you said, I would expect that what I would do is do an options dot type info resolver dot get type info, and then pass that type info directly into the root level methods that accept JSON type info as the parameter, and that should kick off pure metadata based serialization for the value we're interested in. Should I say that again? So
I think I heard what you said. I just still don't understand. So basically, like, it seems like what you're saying is, if you do source generation, you do source generation. You don't actually use custom type resolvers. Is that fair, or is that misunderstanding?
So when you
Yes.
say use custom type resolvers, like what do you want to do? Like add to the list of types? Like what are
the context becomes the
scenarios?
custom resolver in that context.
So with source generation, you specify a list of types that's your entire closure for your serialization. So like what sort of additional things would you want to do? Like
So like, I mean, this is the old example, right? Let's say I write an ASP.NET app. I use the Azure SDK. I would like to make sure that I use the source generated stuff the Azure SDK provides for its own types. But then, for some of my own types, I want to use a custom type resolver because I want to tweak the settings on it. I don't want to put attributes on my types. Does this now mean if I do that, I basically opt out the entire Azure SDK also out of source generation and everything is now reflection based? Or can I say, yeah, but use source generation for as much as possible, only for the types that I would like to mess with? I mean, sure, use reflection for that because I'm doing runtime stuff for those.
That is absolutely that's absolutely consistent with the proposed design, I would think, and you don't even need to fall back to reflection doing that. Like you would be able to write a resolver that composes with JSON serializer context and does a bunch of changes on the contract. I don't see any reason why you shouldn't be able to do that. But that being said, I somehow feel that it invalidates the purpose of source gen. Like the purpose of source gen is that you have this metadata object that is hard coded in C#. Like you just instantiate it, call it, you're done. Now you're doing a bunch of what amounts to reflection, I would say, to make a few changes. And as soon as that happens, why not just use the reflection-based serializer in the first place? Like, it doesn't seem like, I would venture a guess that 80% of use cases that rely on contract resolution really only use reflection-based serialization. Although I could be wrong, but I think that in most cases they want to do some sort of reflection-based querying and modifying the contract at runtime.
I believe you. I'm not trying to make a statement. I'm just saying, like, that's what I was asking in my head. I don't know how they to compose, or if they compose at all.
They do.
I mean,
it sounds like
yeah.
regular...
I think I just don't know what the code would be. So basically, what you said earlier about, yes, you can do that. I just don't understand what code I would write to make that happen, I guess.
I think
you would
it
need...
be...
Sorry,
I just want to say it just sounds like that would be like whatever union strategy we come up with, or we talked about union in the context, union in the resolvers. Context is essentially resolver in this case, so it just seems like it's whatever, like yet to be designed is what I would think. But I don't know if this is a separate like sort of amalgamation than just the stuff we talked about before, or like that we should circle back to.
Like there's a bunch of concerns as well to be addressed. Like what happens if you union, like you said, two different contexts and they happen to define different contracts for the same type? Like there's a whole bunch of concerns around conflicts that
Right.
are probably best left to the user in the first place. And one way of disambiguating would be chaining them in a specific order. But there might be other concerns as well, and it seems like it's something best left to the user, and we shouldn't necessarily be advocating for, oh, this is our default resolution semantics, this is our default resolution order, because I'm kind of guessing that in real world applications there will be all sorts of random types that need to be accounted for from different sources, be it like NuGet packages containing JSON serializer context definitions. Like it could be a bunch of contract resolvers that do a bunch of changes on the property names or what have you. Like these things, I wouldn't expect like one true way of composing them and everybody being happy with it.
Then just the other thing to verify with SourceGen is like SourceGen says use one. So for whatever union of contexts or resolvers, they all need to share the same options instance, I think, conceptually. So I guess the one thing to verify with SourceGen is that you can actually share the options among the different contexts / resolvers. I don't think we have that one-to-one mapping to this. So I think that would just need to be extended, as you said earlier.
We absolutely need tests for that, and we need tests for, hey, I got this random JSON type info instance by calling options.typeinforesolver.getTypeInfo, and I passed it into one of the SourceGen methods that take JSON type info as an argument. Like this should work, right? And we need to attest for that. But I would probably think that as soon as you write your own custom contract resolvers, I think that the way of resolving metadata that is more natural, that has more mechanical affinity with that abstraction, that would be JSON serializer options based dictionary lookup keyed on type for getting the JSON type info that works for you. I wouldn't anticipate that people would be calling into the JSON type info APIs directly or into the JSON serializer context APIs directly. They would rather use the options-based APIs. Okay.
Yeah, so I guess to me the takeaway is kind of like I would like to see, I guess, a code sample that just shows that, I think. And I think it's reasonable to say it's out of scope too. Like, I mean, I did not try to say like they have to compose, right? What you said earlier about that it seems unlikely that somebody wants to combine source generation and custom type resolution. That's a fine statement too. Like I'm not trying to say we should have it. It's just that the design seems to indicate that they should compose, and I just can't quite figure out what that would look like. And if that always makes sense.
I think we need to get the fundamentals of the design right, and that should mean you should be able to mix and match these things without surprises.
Right. I think that's a fair statement too. I had one more question, like on the JSON type info, the non-generic one. The converter and kind are not settable. Is that intentional?
Yes.
So why can I set the converter on the property but not the type?
For the JSON type info, we already have a mechanism for determining the converter, and that's through the options. So that's the reason we basically didn't want to provide another way to do the same thing. For the properties, it's different because for the properties, okay, you have a default options, but you might want to customize it for this specific one property.
Ah, I see.
And we also chose different naming here because, like, if you don't override it, it's so in here actually it's nullable also.
Right.
So that means, okay, I actually didn't want the default or not.
So you're saying if I don't want to use an attribute on the type, I would just basically put it into the options. That's the way to do it, rather than doing it on the type info.
Yep.
And then the kind is similar, I guess. It's just
no, the kind you don't have a way to specify it. The kind is more like when you're referring, say to, let's say you want to extend the default implementation, and you want to every single possible to every single possible type which has properties or can have properties, you want to add another property for whatever, like version or God knows what, or date time or something. I don't know what people can think of, but and you want to actually know if that thing supports having properties or not. You have to have a way to be able to tell that, and the JSON metadata kind is the way to tell that basically. So if it's object, basically we'll set properties.
Yeah,
and in the future, most likely we'll also add options for those two, and most likely there will also be like object with something with args or something like that.
And the kind enum, the value of the kind enum derives from the converter in the first place. So, if I specify a custom converter for my POCO, then, tough luck, metadata no longer applies. You're using a custom converter and you're on your own. So, if that's the converter we're associated with a given options instance, then it's a done deal. The converter is fixed, and therefore the kind is set to none. And therefore, for all intents and purposes, it's going to be whatever changes you make in the model will be a no-op.
Right. So basically, object enumeral and dictionary can only be returned for things that we understand, that are kind of intrinsic to the way we serialize, right?
Yeah. So dictionaries that we support using the internal dictionary converter.
Right. And then same with enumerable and same with object, right? Object is basically everything that is not custom. Maybe just walk the properties, right?
Right.
Yep.
Yeah. That makes sense.
So I just want to say, like, we have this feature we're considering for 7.0, which is to allow users to have access to the internal converters that we have, like object, dictionary, and things like that. So you slap an attribute like you slap a converter that has like the internal JSON object converter. That I think that sort of interfaces with this kind property, where like if you specify the like object converter for a dictionary, for instance, like, okay, don't modify this as a dictionary, but look at the like properties and stuff on it. So that's one way we're allowing users to modify the kind. So I wonder whether this should be mutable to have like analogous like a way to do it at runtime, basically, as opposed to just design time.
So we kind of considered that, but unfortunately it's not possible because, when you get to the point where you create the JSON type info instance, basically the converter that you're using for that given type is already committed and locked. And therefore, making it possible to change it via a setter in the metadata, it seems like it might be introducing too much complexity to force the change upstream in any of the caches that might contain the previous converter. So I think the approach here should be, specify the custom converter in using the standard way, like going in the options instance in the converters list and assigning it, or assigning it via an attribute, and then separately make any changes you might need in the metadata. Although typically the custom metadata resolvers are not kind of written to act on individual types. Usually what happens is that they kind of apply blanket policies throughout every single type that you're serializing. So I don't necessarily think that this would introduce any awkwardness for people that want to like specifically change the object serialization semantics of a very specific type. That should be configured on the custom converter level.
Yeah. Even the good point there is like you can already do this at runtime by using like options.converters or converters. Cool.
I think one thing to consider with the metadata kind maybe is like I think that was you, Liami, who mentioned on the chat that was I think that was anywhere public, but you mentioned that we might want to add the create object with arcs or something similar, and in that case that would most likely introduce another enum options in here, and now if users check the object and say we add something like object with arcs in the future, then maybe like given that maybe better to make it flags explicitly, because it might end up flags in the future, and just for that reason it might be better to enforce it now. But like that's my forward guessing, I guess.
And I don't understand, like, how can it possibly be flags? Because you have to do, it can't be both, right? It's either, it's one of the things.
No, but
here.
like if it's going to be an option like object with arcs, say, so it has a parameterized constructor, you cannot actually change the properties, but you can set them through the constructor arguments. So in that case, you like maybe would want to know that, and if we create another thing like object with arcs, you technically can still create add properties in here.
No, I think that's introducing too much complexity in the API. Like I think instead we should, when we do
maybe
add,
we should just not ever change it. Maybe that's the answer here.
When we do add support for parameterized constructors, I think it should just work with POCOs. It needs a bit of infrastructural refactoring at the wraps because currently it happens to use a separate converter implementation, and I think that's a good signal that we shouldn't be exposing it yet. Like having a separate flag just because our current implementation detail means that we use a different converter for constructor deserialization. I don't think that's.
Yeah, it might be better to expose it as a Boolean flag or something on the JSON type info, and that would basically expose that option is like something like has parameterized constructor or something like that. That's what I think believe we currently have internally.
Right.
Other question: should we rename JSON metadata kind to JSON type info kind?
I like that. Personally.
Okay.
I mean, that would make a bit more sense to me. I mean, the other thing that I wanted to point out is like if you say like certain things are in the options and done via converters and other things are done here, that also means that whatever combination patterns you are thinking of, you need to consider that they're not complete, right? So you would have to do potentially both, right? You would have to combine the converters in some way, and you have to define how the resolvers are composed, right? If you can't do everything via the resolvers, that is.
I mean, technically, it's implementable to make the converters settable, but like I am on this specific case, I am not sure because let's say let's given a scenario. Okay, let's say I use the default JSON type info resolver and I override it, and now I say base.get type info and I get the something with the converter and the properties. And now let's say I change the converter. Now the properties might change the semantics into something which it was not meant to be. And it might just throw basically at this point because the converter is no longer like able to process the properties which I was given. So that's kind of like they're like really weird places we might get into, like if you make the converter settable, basically that's what I'm.
Yeah, I'm not saying we should. I'm just saying like from a conceptual level, like it seems you basically have two extensibility patterns, right? You have the one via the type info and you have another one via the converter, right? And they, do different things, but there's some overlap, right? And that poses challenges when you think about how they're composing, because now you want to compose, you basically have to compose the converter somehow, which is a list, and then you have to compose the type infos, which is a singleton, basically. Then you have to like somehow build an instance for that, right? And because of that, it might be challenging to define what code you need to write, because it's like, oh, for converters you do one thing, for type infos you do a different thing, and but they are not orthogonal, right? Because they interplay. Like there's only one combination of things that actually works, right?
Yeah, I can maybe try to clarify the ontological relationship between JSON converter and JSON type info. JSON converter is the more general mechanism. It's the more generic mechanism, but the problem is that if you want to write a general purpose converter for POCOs from scratch, that's a lot of work. So what JSON type info is, it's basically the configuration object for default converters that we currently have internally. So there is, even though it pretends to be an independent feature, it is strongly coupled to whatever converter we happen to have subscribed for a given type.
Right.
Wait, there was a statement. Quick question. There's a statement about like if you are in a converter, you're sort of on your own, and then metadata doesn't apply. Is that true, especially with like new models, like where we want? Because users complain today about converters being difficult. They're mostly for primitives, but then you might want to have like a converter to handle, objects, and then you want your list of properties. So I'm like, how does that statement like hold? Is there like more of a interplay between those two concepts? I think that is the current discussion, but like I wanted to talk about that feature specifically, like being
So
able
basically, you want to write a custom converter which is able to pass properties, to parse properties, or like what?
Right, like so. It's
Yeah,
not
like
like you have a
that's possible, like one future extension point. So basically, like I kind of think of it as the JSON type info being like a bag of properties the converter is using. I am not kind of constraining this, like in my mind at least, that this is an internal converter specific, but like currently it is, because the converter you kind of don't have access to that, or in the future technically we could allow access for the JSON type info inside the converter and then be able to read that bag of properties essentially. So in theory you could, in the future we could create something like a converter which writes in example a type rather than as the JSON object. It could write like, I don't know, like an array and write a purely list of, so basically like every other value would be a key and the other one would be the value, so something like that. That could technically be done in the future, but it's technically not constrained to that, but like currently it is, because we don't expose it anywhere in the converter.
In any case, like the main thing is that writing custom converters is hard for like arbitrary types especially. And the other thing is that custom converters are fundamentally restricted because they do not pass serialization state and they cannot be async at the moment. So that basically, and that was actually one of the main issues, one of the main reasons why James contacted us in the first place, because he actually did that. He wrote a custom converter for his gRPC model because he can, but he immediately ran into performance issues because lo and behold, the custom converter was buffering the entire contents of the serialized or deserialized JSON. Like it's an unfortunate design issue with system text JSON and its custom converter model, and JSON type info will give us access to configurability for the baked-in converters that support async, support threading state, like do all these fancy things that users would otherwise need to implement by hand. Reference preservation, polymorphism, you name it.
So quickly, as it relates to this type info kind, do we need another one that says converter, especially read that comment saying contract metadata doesn't apply here? Like,
sorry, could you repeat the question?
Do we need another like kind that says like this is a custom converter or not? Like it's none.
Isn't that what
basically everything other than none is like built-in converter currently?
Yeah, but like, do we need to? I guess I'm just uncomfortable with that comment saying contract metadata doesn't apply here, and as that like it might in the case of custom converters in the future. So I don't know whether the solution is to add like another field there, but like it seems like we should be able to express that somehow.
Honestly, I wouldn't distinguish between custom and non-custom. Like I think this is currently artificial concept, which in the future there might be no difference. But so I'm kind of opposed to adding things like custom or not custom.
Yeah, like from the bounded context of JSON type info, like it doesn't matter to make the distinction.
One other question is like, isn't the kind really the converter kind?
No, because actually converters
Yes.
being kind of a superset of converters that are configurable via metadata, you can have other things like primitive converters or custom converters. And I would expect with a feature that we actually pushed out of 7 recently to have more kinds of converters that are user definable. But as far as from the perspective of metadata, from the bounded context of customizable metadata, you have these 3, and then everything else is no op.
So I guess what I'm saying is like, isn't logically speaking the supported kind or the kind on the JSON type info, does it not depend on the instance of the converter that is attached to it?
It does.
Yeah, but we do have the converter strategy type, which has the exact same fields. I assume that we're just renaming that here.
Actually, no. Like it has
almost
more
the same
fields.
So we removed a couple of fields like value because it currently means something else than it suggests. So we remove those. So yeah, basically current implementation. This is actually called, I believe it's called like a JSON converter strategy or something like that, and it has a couple of more things. I believe it's at least values, and the values means custom or what did it mean, Eric? Can you remember?
That is exactly what it is. Just
value or custom. I think it was value or custom converter, which makes it super confusing. And we decided to basically allow users to see this, but in a slightly constrained way.
It's also used as a flag internally, so it wouldn't be appropriate to surface it as flags in this context. So essentially, we're mapping the internal enum into this enum that is appropriate for consumption in metadata customization.
Yeah, that's why I was asking whether it should logically belong on the converter in the first place, if it's kind of a function of that anyways.
I mean, honestly, like my initial proposal didn't have this at all. I would kind of have some, if user wants to change the type, they would probe on the type, so they could technically check like if the type is assignable from like a dictionary or something along the lines. So this way they could check if they're on the dictionary or numerable, but they don't have 100% solid way to check if they're actually on the object and if we're gonna if we are going to actually process the properties or not. Because if someone assigned their custom converter, now I would have to do those check, plus if this is my custom converter. So there's basically no good way to check it of however I think about it. But on the other hand, it's not really a common scenario to do that at all. So but there are some scenarios. Basically, I think like this specific sample over here like actually does use it, but in theory like so this specific sample actually needs it, but and I'm not sure if there would be a better way to write this.
This is like you could just check for no on properties.
Well, that was discussed, but ultimately, you will have a bunch of knobs that would be applicable to specific kinds, and trying to set them in a kind mismatch would throw invalid operation exception.
I mean, for now, currently, it's only about the properties, about properties and objects. So basically, that's the only thing we
in the current
have to consider now.
In the current MVP, but we are planning on adding knobs specifically for collections and for dictionaries.
That is true, but they might end up being on the converter and not on the type info itself. So we don't actually know yet. So that's the idea here.
All right.
So let me post the comments I have. I don't have that many because most of the stuff we talked about was just me, I guess, trying to understand what it is that you have. Well, I need to find the issue.
Let me share it.
Yeah, let me paste the link in the chat.
Runtime.
So what do we do about this now? So basically, do we continue the conversation, or like how do we proceed from here?
I mean, honestly, for me, the two things that I think need some thought, I think, is the combinators and whether we need to solve it or not. And I would suggest we should at least design it and convince ourselves that we don't have to ship it, or decide that we should ship it. And then the other thing is effectively, have some sort of sample or opinion on, I guess, how source generation and custom resolvers interplay.
Makes sense.
But other than that, I think it looks like a pretty solid proposal already. But based on these two open questions, I would be inclined to say mark it as needs work, and then you come back with the updated thing.
Sounds good. Do we have any schedule? Like, what's the earliest we could pick this up next? I guess I don't know if you have any. I know this week is already booked, so probably maybe next week would work for you. So I'm pretty sure I can.
Would it make sense for us to take some time to work on the acceptance criteria, work on the code examples, work on the combinators, and file APR, and then come back to API review? I think that would be then we would have good proof that all of these questions have been answered.
Yeah, I think it's just a matter of a couple of samples and the solidifying the combination APIs, like an example combination.
I mean, we have 2 slots, right? I mean, you could literally come back on Thursday if you wanted to. Or we could say next week, right? It depends on how soon you want to come back.
Okay, I will let you know, because I don't know if I will be able to make it by Thursday. Okay, thank you.
Sounds good.
Yep, thank you, and goodbye.
Goodbye, everyone.